Okay, example 8. A 90-foot cell tower is located at the top of a hill. An observer 200 feet down the hill measures the angle between the bottom and top of the tower to be 19.6 degrees. Determine the angle of inclination of the hill to the nearest tenth of a degree. So the first thing is we want to find the angle of elevation, or sorry, the angle of inclination of the hill. That's not totally obvious to me how to do that at first. So the first thing I'm going to do is do what is obvious, and that is to look at this triangle. That's pretty obvious. And go ahead and use the law of sines to find angles B and C because I'm given all the other things. So I'm going to say sine 19.6 over 90 is equal to sine B over 200. If you cross multiply, you're going to have 200 times sine 19.6 is equal to 90 times sine B. And then if you divide by 90, you're going to be here. And then so inverse sine of that stuff is going to be angle B. And you can see already that angle B is acute. It has to be acute because angle C has to be obtuse, because if you're at the bottom of the hill looking up and the tower is straight up to the sky, then that's going to be an obtuse angle at C. So B will be acute, and we don't need to worry about checking both possibilities because it's a real life situation. It can't be anything but acute. So we punch that in, we get about 48.2 for B. And then we can subtract from 180, 48.2, and the 19.6 we had already, and we get 112.2 for the obtuse angle there at the base of the tower. Okay, so I took out everything out of the picture that we don't need, and there's a flaw in this picture actually because the tower is supposed to be straight up, and the tower looks like it's leaning backward a little bit. So that's not really the case. The tower should be perpendicular to the ground, and the ground at the bottom of the hill is supposed to be parallel to the ground at the top of the hill. But anyway, so the angle of inclination of the hill is this pink angle down here at the bottom. I'm showing two horizontal lines that are meant to be the ground, the horizon, the true horizontal, true level, at the bottom of the hill and at the top of the hill. Those are meant to be parallel. And so the angle of inclination of the hill down at the bottom, it's above the ground, and the line that is cutting through that, the slope of the hill, creates an angle there called the angle of inclination of the hill. The same angle is created at the top with that line, same slope of line, and the horizontal ground at the top of the mountain. So I'm going to call that angle alpha. And we can use the angle we know, 112.2, to find out what alpha is, because there's another angle here that we could call beta. And you can see that beta and 112.2 form a straight line. So 180 minus 112.2 is going to give us 67.8 degrees for that beta right there. And beta and alpha make a right angle. So 90 minus 67.8 is going to give us 22.2 for that angle of inclination at the bottom of the hill.